Hello, algebra. We're going to start chapter 2. Chapter 2 is about equations. So far in algebra, we've only talked about expressions. So when we're talking equations, we're looking at two expressions. That's spelled wrong. That are the same value with an equal sign in between. Okay? When we're solving equations, we're doing that for a very specific reason. We are doing that to find the value of the variable that makes both sides equal. Okay? So it's really super important that we pay attention to that. Let me ask you this. Are these two things equal to each other? Or are the, come on, perfect equal imperfect? Are they equal to each other? Okay. What would make imperfect true? Well, the only thing that in this world that has ever been perfect, completely perfect, never sin, never do anything wrong is Jesus. Okay? What about sinless versus sinful? They are not equal, right? So what would make that equal? What would be the value over here? Again, it would be Jesus. Okay? Jesus equals death. Is that true? Does Jesus equal death? He doesn't. So he does equal getting the Holy Spirit in our hearts and ultimately having God in our hearts. Okay? So as we are looking at that, that's an indication of what an equation is, or value an equal sign. All right, let's look at an example. As in other lessons, we're going to use some pictures, and we're going to use those pictures to help us look at how equations are balanced with each other. Okay? So I want to look at this equation. 2x plus 2, that's an expression, equals 6. Also an expression. It's a constant, but it's still an expression. And these two expressions are set equal to each other. But we don't know what x is, and we need to figure out what that is. So in doing so, we're going to use a picture to do that. So we have what kind of terms in there? We've got x terms. We have positive constants. And if we had a negative constant, we would put an open box. So positive x terms would be rectangles colored in. Positive constants would be a little square colored in, and a negative constant would be a open circle. So we want to draw a picture here. So we want to draw a picture here, and when we draw that picture, we want to make sure that we have drawn what is stated in this problem. So for our picture, I'm going to use green, and I am going to put two x's on this side. No, I want that to be green. Okay, I'm going to put my two rectangles over here, and I'm going to color them in because they're positive. So I have two x's, and I've colored it in. What else do I have if we would split this in half? What else do I have over here on this side? I have two constants. So I need two little boxes, both colored in. Okay, so that's my picture. And then over on the other side of the equation, so that would be this side of the balance, I would want to draw 6 of these little boxes. All colored in because it's positive. If it was negative, they would be not colored in. Okay, now, here's the thing. We need to make our balance level. So to make our balance level, we need to have just x's on the left side over here, okay? So these two constants right here, they need to go away. These two constants need to go away because these are all constants over here, right? So we learned last chapter that if we have a positive and we add a negative to it, we can cancel it out, okay? So what I'm going to do is I'm going to take a negative box and I'm going to put that right here. Oops, shoot, I don't want it colored in. Okay, pretend that's not colored in. There we go. And then I'm going to take another negative box and those will cancel each other out. Okay? Now, if I do that on this side, then, and I don't do anything on this side, then my balance isn't going to stay balanced like it is. Notice my line right here is flat. If I just did that on this side, if I took these two off over here, but didn't take two off over here, I wouldn't be balanced. So I need to remove 2 from this side as well. Okay? That'll cancel that out, and that'll cancel that out. And so now I have 1, 2, 3, 4 left over here. Okay? All right, so I want to reorganize those 4 that are left. So I reorganized them so that they're in 2 separate piles. And I did that because I have 2 x's. And so I want to know what 1x is equal to. So I separated my 4 into 2 separate piles. So look at this. So now I can say that one of these x's has 2 pieces in it. Digital equation. And I'm going to take that x equals 2 and put it in for my x. As I do that, I'm going to then just do what we've been doing as far as evaluating. So I'm going to evaluate this equation. Here's my equation with that 2 substituted in for the x. So I get 2 times 2 plus 2 equals 6. Now I'm going to use PEMDAS. I have to do my multiplication first. 4 plus 2 equals 6. And then I get my 4 plus 2 is 6. 6 equals 6. So I'm just evaluating that left side. And those are equal to each other. Right here are equal to each other. So my equation works. So this is super important because we want to know what x is equal to. And we're able to check if we're right or wrong. So with that said, let's move on to a second example. Okay, 3x minus 7 equals negative 10. I want you to build that equation on your balances. So draw 3 x's, 7 negatives on the left side, and then 10 negatives on the right side. Should look like this. Pause your video to draw that picture. Okay. Now that you have your picture, we want to cancel these x's out. So we can do that using positive x's. So I just used a green marker for my positive x's in this case. And you'll notice I canceled out 7 of them because of this minus 7. Here, I want to get these out of here and move them over, on both sides. I want to get rid of 7 on both sides. So I did that by essentially adding 7 positive squares and that would cancel out each of these. And then added 7 positive squares over here, which canceled out 7 of those. And so now I have this picture, and I have 3 x's on the left side and 3 units on the right side. Now, if I do what I did before and I put those into, I organize them so that they're in 3 different piles because of this 3x, look at the picture. Tell me, what is 1x equal to? 1x is equal to -1. So x is equal to -1. But here's the thing. Now I need to do my check. Let's make sure it's right. Okay? So I take my original equation, I put my x minus 1 in where the x is, and then I check my work. Put my x minus 1 in. Now I need to multiply my 3 times my -1. I get -3. -3 minus 10, or -3 plus -10, right? We want to think of that as adding a negative, is, I said -10, -7. -3 plus -7, if we add those together, we indeed get -10 on the left side, and -10 is equal to -10, so my answer for my x is correct. X does indeed equal -1. Okay, let's try one more and build that picture. So I'll draw 5 negatives on this side, 5 negative x's on this side, and 2 negative units on this side, and then draw 3 units on the other side. Okay? So, with that said, pause that video to do that, and your picture should look like this. All of these are red, they're all open because they're negative, and over on the right side, those 3 dots, or those 3 is represented by 3 squares that are colored in because they're positive. Okay, so what's my first step? My first step is to get all of these x's by themselves and move these guys over. How do I do that? Well, I add some positive x's. So I can add those positive x's on this side, and you'll see I added 2 positive x's on this side as well. And these are going to cancel. And so then, without those there, I can separate this into 5 piles. Separate everything into 5 piles because of my 5 x's. And 1 negative x is equal to 1 positive 1, right? Negative x is equal to positive 1. But here's the thing. Our answer can't be a negative x. It has to be a positive x. So I need to take and change that positive, just change this to be positive, and then change the sign on the other side. And now that's my answer. So let's check. My equation is negative 5x minus 2 equals negative 3. So I'm going to put that negative x in for my x, and let's see what happens. When I've got that negative x in there, or negative 1 in there, I've got negative 5 times negative 1, which is positive 5. Subtract 2 from that, or add negative 2 to that, and I get 3, and 3 does indeed equal 3, so that one checks out. It's super important, as you are getting used to this, to check your answer. So you're not doing any math other than plugging in your value for x and then solving over here. So this is not an area to do any math. This is an area to check if your answer is correct. Okay? I believe this is our last one. It's really huge numbers. So no, I'm not going to make you draw all of that. So here's how it looks. Oh, we have one more after this. So I drew 7 X's, I drew 13 blocks, and 55 blocks on the other side. Okay? These are positive blocks, so they're green. I want to add negative 13 to that to cancel that out. So here's how I did that. I add my negative 13. I add negative 13 to the other side. These ones cancel. 55 plus negative 13 is 42. Okay, now I need to take this 42 here and I need to break it into 7 piles. So I basically am dividing 42 by 7. And when I divide 42 divided by 7 is 6. Great. So 42 divided by 7 equals 6. So now I'm going to test that, check it out by putting my 6 in to my X. And now I can evaluate that and see if that works. So again, we're just doing a substitution over here into our original equation. We're checking to make sure this answer here is correct and doing the math. So 7 times 6 is 42. 42 plus 13 is indeed 55. Remember, we do our work going down. We haven't done anything with the right side, and 55 equals 55. That checks. Okay, one last example, again with bigger numbers. So I'm going to keep my 22 just a box of 22. So this is my equation built. Write that down. How am I going to get rid of these negative 2's over here? What do I have to add to it? 2 positive blocks. Okay, so that's what that looks like, and those will cancel. Notice I added them on this side, and I added them on this side when I add my positive 2 blocks. Okay. These ones cancel on this side over here. And now what do I have on this side? How many total do I have over here on the right? I have 24. Okay, so here I've got my 6 X's. So my 6 X's, and that is equal to this 24. And if I were going to break this 24 into 6 equal piles, I would just divide this by 6, okay? And I would get X equals 4, okay? So what do I have to do? I have to check my answer. So you write down your equation. Put that 4 in for your X. Do the math on the left side. So 6 times 4 is 24. 24 minus 2 is 22. And 22 equals 22. It's good. All right. So think about what's happening. Look at the pictures. Rewatch the video if you have to, and God bless.